now actually moved. I'm now based in the States at Harvard School of Public Health, very kindly funded by the Commonwealth. Thank you. So, yeah, this is a terrible title. This is very academic, but what we're thinking about here is how you can take what patients are saying in their real words and use a computer to try and understand more from it and sort of learn from the crowd of patients who are out there. So we know that we really love using the internet to rate things. It's become totally part of normal life. When I book my hotel to stay here, I look to TripAdvisor, as do about half of the American population when they're booking sort of their holidays. We rate and review the products and the services we buy, whether that's a book online or the seller of something on eBay. We now starting to extend this into other services and healthcare. And these are some of the websites that you can do this on. Rate and review your hospital, your individual physician, and these are the English ones, but I know there's very similar things over here. Angie's List, Yelp, and you know, they're kind of catching on. People are using them. Not everyone, but they are using them, and use is increasing. This is data from the US and the UK that shows the frequency of rating. I think this is from Yelp. No, that's from RateMD's, and that's from the NHS's big website. That's the big National Health Service in England. And you can see that over time, the number of ratings is increasing. Slightly faster in the US, possibly a result of your slightly more consumerized attitudes towards healthcare than we have in a large socialized healthcare system at home. But so rating is happening and it's going up. And there's another sort of really important thing in healthcare quality. Most definitions of quality include this notion of patient experience. In fact, all of them do these days. But we really struggle to measure it and to think of good ways to look at it and capture it and take this information and use it. So for example, we have big surveys of patients. We do. National one. We have one in England. Over here you have HCAP. The English one, the data, when we ask the patient, when the patient receives their care, the delay from that to when the data arrives in the hand of the chief executive of a hospital is about 11 months. So this is not great, useful information for actually improving the services. There's a real delay, and you only capture a small proportion of patients' experiences when you look at surveys. They can only ever capture a part of it. So it's been conceptualized before that there is a sort of a cloud of experience that exists online. So whether it's on social media platforms or ratings websites or blogs or Twitter, or even in the comments pages below local newspaper stories, where people are really talking about their care. But we struggle to look at this in any sort of systematic way. And the problem is, it's free text. This is a nightmare analytic. This is really hard to take and condense and to bring together and use as sort of a marker. And I don't need to tell an audience like this about big data, which may be approaching the wrong end of a hype curve at the moment. But we do see that you can use new analytical strategies to take real-world data from these social media and try to look and see if there's any relationship with actual phenomena in the world. Can you use Twitter to predict a stock market closing price? Well, kinda. Can you predict an election result? Well, sort of. And people are starting to use some of these techniques in healthcare, particularly around data within the electronic medical record, clinical data. But I haven't seen much going on in terms of looking at the patient's own experiences of care. And we've got these ideas like sentiment analysis. Well, when you look at language, you can look at the polarity of comments about certain topics. Are they positive? Are they negative? Well, hang on. This is really very relevant to what patients are doing. So we thought we'd have a look at this. And we're lucky in England. We had a natural experiment. This rather ugly webpage is taken from the English NHS's big website. It's nhs.uk, NHS Choices it's called. And you're allowed to rate hospitals. We've been doing this since about 2005, 2006. And it's got two very useful components, from my point of view. It's got free text stories about how people understand their care, and it's got ratings, meaning that we've actually got sort of the scores on what people thought about their care in a numerical form, and this is useful for any machine learning task. So this is the method. This is a scientific presentation, so we must have method. I applied legislation to this building here. So this is our Freedom of Information Act, and this is our Department of Health. It's just over the road from Downing Street. It's a rather sort of ugly modern building, and this is where all the great decisions get made. And to my surprise, I said, look, please may I have all of the patient experience data that you've collected over the last 6, 7 years? They said yes. And now they've put it out in public, so anyone else who wants to use this data can use it as well, which is good. And so we did. So we went through some machine learning processes to see if we could predict patients' ratings of their care from their free text experiences. So this is where it gets a bit technical, so I'll try and go through this fairly quickly, but I'm willing to talk to anyone in more detail about it later on. So we need to make an algorithm that can look at the free text, you need to teach. So we took all of the comments from the first and all of the rating, and we put them and we fed them in to an algorithm, and then we tried to predict 1 year's worth of comments to see what ratings were associated with. And we tried to predict 3 different questions: whether the patient would recommend the hospital, whether it was clean, and whether they were treated with dignity. And so technically, again, we used a couple of tactics. Prior polarity, we identified the 1,000 most common words and 2-word phrases, and we ascribed where we thought there was a meaning to them, either positive or negative. We told the computer what we thought they meant, so sort of words like dirty, probably negative. We used information game, which sort of selects the most important words in that process, and sort of tries to maximize the algorithm around it. We used a bag of words approach. You sort of pour all the words together into a big pot, and we used quite short n-grams for this study. So these are 1 or 2 word phrases being put into the mix. And we tried different classification approaches, which are the ways that you teach the algorithm to learn. And we used open source Weka software, which is a lovely open source program from New Zealand. And so hopefully this stuff is reproducible. This is easy to get hold of, and the data is also get hold of-able. But let's just take a moment to think about sentiment analysis, because it can be really tricky. Simple things, simple bits of punctuation, contain an awful lot of meaning. This looks like a humble, innocent bit of punctuation, carries very little meaning. At another punctuation mark, it has a lot of meaning. A very small change means a very big change in sentiment. So this stuff is, but thankfully, algorithms these days can detect this sort of thing. So what were the words that kept coming up that were important? Well, here's a sample, and they kind of make a bit of sense. Rude, not good. Dirty, not good for cleanliness. If anyone mentioned a floor, it tended to mean that cleanliness wasn't great. Some words are interesting. Told. Turns out patients don't like being told stuff. Who'd have thought it? So a bit of science again. What works best? So we tried different approaches. Here they are along the top. And we looked at 2 different things: how precise they were in classifying, that's kind of accuracy, and how quickly they did it. So you've got to remember, this is a 2-way classification, up or down. So we get 50% chance right by guessing. But using our algorithms, we were getting it right between 80 and 90% of the time. But some of them were much faster than the others. So in the end, we decided that for this purpose, a naive Bayes multinomial algorithm was best. Yeah, there we go. And actually, when we looked at the 3 different questions we asked, we got the same thing. Between 80 and 90% of the time, we could get it right. And it's all highly significant. So we thought, okay, so we can do this. We can reasonably accurately predict what people think about a hospital from their free text. But does it compare to real-world data? This is the test. So we took our big patient survey. And this is the one that's done nationally. It's 2,000 responses. It's big, it's proper, it's kind of the gold standard for patients in the old world. And we compared it. And going back to statistics again, this was Spearman's rank correlation coefficient. We see correlation coefficients of around 0.5, which is a mild correlation, but highly significant. So there is a relationship between the information we capture online through free text and real-world patient experience via the conventional routes. There are problems. There is a selection bias. We are only looking at the views of people who have chosen to leave their reviews online. These are not normal people. Well, these are people who have experienced good care or bad care. They are the engaged patients. Really valuable, useful views to have, but they are not the views of a statistically normal therapy. This is English data. It's full of irony and sarcasm. These are horrible to deal with. It's culturally specific, for example. I mean, there's some words that you kind of get an idea about, like This is positive in almost any context. It's negative in almost every context. This is very confusing. This is very English. I don't know if my data would work on your data, because I doubt this is quite as important in an American data set as it is in English. But cup of tea comes up a lot, and it's very emotive, but it can be really emotive depending on the context it's used in. The nurse even made me a cup of tea. She didn't even make me a cup of tea. Terrible. So, like, until we can, and our algorithm can't deal with it. So until we can work out something better that understands nuance in this sort of way, I think we're not quite there yet. I mean, so if we've got computer scientists in the room, they'll know that the computer science we're using here isn't super hard. This is kind of not cutting edge. This is kind of the other end. But what is interesting is that we can compare it to real data, and it does work. And so it leads us with, well, this is all very interesting and academic, but what can you do with it? And this is where I don't know. We could scrape these various sources and try and get this cloud. We could see if we could. We've had a series of care scandals where care really wasn't very good in one or two hospitals in England. And kind of the patients knew about it at the time, but the system took ages to pick up on it. If we had a system that tried to collect all this at once, could we get a slightly earlier in on that poor performance? I don't know. And this is fascinating, I think. You know, it kind of works, I think. Is it useful for a health system to improve or for a patient to use? This I don't know. This is what I'd like your view on. But having said that, this was published 3 days ago by the NHS in England. This is real-time data about, so social media data about the NHS. And you can look at either the NHS as a brand, interesting but not potentially super relevant, but you can actually look at specifically about hospitals. And this is experimental data that they're now publishing in real time. But, actually, there might be some things that we can usefully do here. Anyway, so I should say thank you again to my generous funders and to the people at NHS Choices who allowed us access to this data. And they did it all right. They have now put this data in the public domain so anyone can use it and access it and do work on it. Yeah, that was good. So at this point, I'd just like to wrap it up and say, I think there's some interesting applications of new technology and techniques being used in other industries for healthcare. I think the real test is to build something that is useful and helps the health system improve. That's the bit I'm still working out what we can do, and I will comment.